Hello and welcome back to the online lecture of Fundamentals of Computer Organization and Embedded System. In the last video, we introduced to the input-output module. So we proceed with the input-output module further. Let's have a look at the input-output module block diagram. So this is the block diagram of input-output module. So we'll see how the input-output module gets connected to the external devices using the external device interface logic. So the external device gets connected to the other peripherals using the data, status and control lines. This is what we discussed in the previous lecture. In the last lecture, you have IO logic that takes care of the selection of the input devices, and the control lines and address lines deals with the selection of the peripheral devices and storing the address of the input devices respectively. You have data register that stores the data accepted from the input devices for the temporary purpose till the data is passed to the memory or the processor. Also, you have the status and control register that keeps the information or that stores the status of the key input-output devices and also selects the input devices that are required to transfer the data between the device and the processor or the memory. This is how the input-output module works as the interface between the devices. On the one end, it acts as the interface to the external device, and also it acts as the interface to the system bus. So the data moving to and fro with the help of input-output module. The help of input module between the peripherals and the. So it acts as an interface in the form of control data and status signals. The control signals take care of executing or firing the commands like input or read. So whenever the processor wants to read something from the input-output data or write into the input-output module, so it executes the input, or it sends the control signals of input or read data to the IO module, writing of data to the IO module, or reading the data from the input-output module. It also reports the status of the input-output devices using the control signals, whether the device is ready to accept the signals or not, and perform some control operations. Like in the case of hard disk, it takes care of positioning the disk head to the required sector or the block to read data. Then you have data, the set of bits that is sent and received from the input-output module. So data is any data that is read and written into the input-output module. So it's a set of bits. And the status signals, the status of the device, whether the device is ready or busy with some other activity. So if the device is ready, then only the data transfer is done between the input-output module, input-output devices and the peripherals. If not, the data is not transferred between the input-output module and the peripherals. So these are the function categories of input module: control and timing, processor communication, device communication, data buffering and error detection. So under control and timing, the processor communicates with one or more external devices depending on the programming needs. So in case the processor is executing some program or the process, and if the process requires some input-output from the user or the keyboard, or some input from some data from the hard disk, the processor communicates this to the input-output module with the help of these functions, control and timing. In the data transfer, the system bus is shared between the processor and the input-output module. The system bus takes care of the system bus is used for transferring the data between the input-output devices and the memory. So that includes the control and timing. Control is basically taking over the control of the system bus for the data transfer, and timing in how much amount of time the data is transferred. So it also keeps on checking for the system bus in between whether it is available for data transfer or not. The control of data transfer involves the following steps. The processor checks the status of the attached device. The processor interrogates the input module to check whether the device is available or not, or the ready, or whether it is ready or not. Send and receive the data. So input module returns the device status if the device is ready or not. If the device is operational and ready, the processor will request the data transfer by some commands to the input module. So the processor requests the data transfer. The IO module obtains the data units from the external devices, and data is transferred to the processor. So this is how the control and timing functionality of IO module executes. So each interaction, so whatever interactions occur between the external device and the input module, so each interaction involves one or more bus arbitration. Now here arbitration means the input output module has to take over the system bus from the processor and use the bus for data transfer. So in this case, one or more times the input output module takes over the system bus for data transfer. That is what is known as bus arbitration. That is the stealing of cycles. Processor communication. Input module is used for communicating with the process. So the processor communicates with the input module. For processor communication, the input output module has to decode the commands that are received from the processor, like read sector, write sector, seek track, scan, etc. These commands are decoded by the input output module to identify which device is to be used and what is to be done with the device. Data exchange. The processor also instructs the input output module to exchange the data between the processor and the module. So what bus is to be used for data exchange, so this is again decided by the input output module on receiving the instructions from the processor. Status report. The input module also specifies or provides the status report of the devices, whether devices are busy or busy or they are ready for the data transfer. It also identifies the address. So on the request from the processor, the input output module has to identify the input output device or the peripheral device with the help of the address. So each input output device has a unique address that is again maintained by the input output module. So whenever the processor requests for some input output device, the input output module recognizes using the address of the input output device. Data buffering. So is one more functionality of the data of the input output module. So input module stores consist of the registers. So whenever there is a data transfer between the processor and the memory or the processor and the input module, the data is stored in the temporary purpose in the registers of the input output module. So as processors and memory have high data transfer speed, so the external devices cannot cope up with the processing speed. So the data is stored into buffer when read from the memory into the input output device and vice versa. So if something is to be fetched from the hard disk or the memory from the memory to the hard disk, so the data is stored into the input output module in the registers of the input output module, and from there the data is transferred to the hard disk or the monitor or any other peripheral devices. Input output module is also responsible for detecting the errors and reporting it to the processor. So errors can be mechanical. So in case some device is not executing or there is some problem with the device, the printer, there's a paper jam in the printer and so on. So such mechanical errors are identified by the input module and are informed to the processor, and accordingly the actions are taken by the processor. And it also identifies the unintentional changes in the bit pattern. So something is being transferred and there is some changes in the bit patterns, the data sent and received. So this is also again identified by the input output module. So it uses error detection code to identify the data transmission errors. So these are like example like parity check, the even parity and odd parity check, that is used for checking the data, the bit changes in the data it is sent from the IO module. So this is how the input output module performs the data transfer between the peripheral devices and the processor. So in this lecture we saw the functionalities of the input output module. In the next lecture we'll discuss the techniques that are used to carry out data transfer between the processor and the input output module. So various techniques utilized for that we'll discuss in the next lecture. I hope you'd like the video. Thanks for watching the video. Goodbye.